Dear students, good morning. How are you? I am your physics teacher, Shafiq Malik, from Pakistan International School, Doha, Qatar. Welcome back. I hope you have enjoyed summer holidays. As you know, this is our 9th week of blended learning. Before summer holidays, we started chapter number 7, Electricity and Energy. Today we will discuss more topics of this chapter. Therefore, all of you please open your science book, page number 95. Learning Objectives. At the end of this lesson, students will be able to explain the importance of fuses and circuit breakers in mains electricity circuits, calculate the value of current, recognize that electricity must be paid for.
Dear students, today our topic is safety and electricity. Mains electricity makes our lives more comfortable, but it can be dangerous if not handled correctly. To prevent damage to property and danger to life, household circuits have built-in safety measures. The first device is fuse. Fuses. A fuse contains a thin piece of wire which will melt if the current gets too high, and leave a gap in the circuit. This stops the current, preventing the overheating of electrical circuits, which may cause a fire. Fuses are put in the live wire close to the electricity meter in a box called the consumer unit. When a fuse in the consumer unit blows, it must be replaced with one of the correct size. It is very dangerous to use anything other than the correct fuse. Dear students, in this slide, the first figure is of a fuse, while in second figure it is fitted, and in third figure, there are few fuses, which are fitted in consumer unit. Dear students, the next device is circuit breakers. Some consumer units have miniature circuit breakers, M, C, B, in them instead of fuses. A circuit breaker is an automatic switch which turns off the current if it gets too high. Unlike a fuse, a circuit breaker can be reset. For extra safety, when using extension cables to potentially dangerous appliances such as electric saws and drills, a current circuit breaker should be used. Dear students, in this slide, the first figure is of a circuit breaker, while in second figure few circuit breakers are fitted in consumer unit. Dear students, our next topic is choosing fuses. The main fuses in the consumer unit protect the house circuits from damage due to too much current. However, each appliance can also be protected by a fuse in its plug. Plugs are a safe and simple way of connecting an appliance to the mains. If the current gets too great, the fuse wire melts and breaks the circuit. When this happens, we say that the fuse has blown. Fuses can be purchased which blow at different currents. Dear students, in this slide, the first figure is of a plug, while in second figure, a fuse is fitted in a plug. Choosing the right fuse. A plug is usually fitted with either a 3 ampere, 5 ampere, or 13 ampere fuse. The value tells you the current needed to blow the fuse. It must be greater than the normal current through the appliance, but as close to it as possible so that the fuse will blow as soon as the current gets too high. Dear students, 3 fuses are given in this slide. First with red color, whose value is 3 ampere. Second with black color, whose value is 5 ampere, and third with brown color, whose value is 13 ampere. Calculating currents. Electrical appliances are usually marked with their power rating, which shows how much electrical energy they convert in each second. Electrical power is measured in watts W and kilowatts kW. Dear students, here, W is the symbol of watts, and kW is the symbol of kilowatts. It can be calculated using this formula: electrical power is equal to voltage multiplied by current. If the formula is rearranged, the current can be worked out by current is equal to power over voltage. Or I is equal to P over V. Here, I is the symbol of current. P is the symbol of power. And V is the symbol of voltage. Calculating current in electric drill. Dear students, in the image, which is also given on your book, page number 97, we can find that which fuse is required for different electrical appliances. For example, first is electric drill, whose power is 500 watts, and the alternating voltage which we receive in our homes is 250 volts, so the current can be calculated as current is equal to power over voltage. Or, current is equal to 500 watts over 250 volts, which is equal to 2 ampere. This means that, in order to protect this electric drill, we fit a fuse of 3 ampere of red color in the plug of electric drill because current through electric drill is 2 ampere, which is less than rating value of 3 ampere fuse. I hope you have understood this. Calculating current in toaster. Dear students, the next is toaster, whose power is 1000 watts, so the current can be calculated as current is equal to power over voltage. Or 1000 watts over 250 volts, which is equal to 4 ampere. This means that, in order to protect this toaster, we fit a fuse of 5 ampere of black color in the plug of toaster, because current through toaster is 4 ampere, which is less than rating value of 5 ampere fuse. Now you tell the reason that why we use 13 ampere of fuse in kettle, given on this slide. Dear students, today our first topic is paying for electricity. Most household appliances get their electricity from the mains. When the appliance is plugged into a mains socket, a current flows. In the appliance, electrical energy is changed into another form. For example, a light bulb changes electrical energy into light and heat energy. This energy has to be paid for. Appliances usually have their power marked on them in watts. The symbol of watt is W, or kilowatts, and its symbol is kW. The greater the power, the quicker the appliance takes energy from the mains. The energy supplied depends on the power of the appliance and on how long it is switched on for. Dear students, electricity supply companies measure energy in kilowatt-hours. It's abbreviated as kWh. Means K for kilo, W for watts and H for hours. Kilowatt-hours are also called units of electricity. For example, if a 1 kilowatt toaster is switched on for 1 hour, then 1 kilowatt-hour, or 1 unit of energy is supplied. If a 500 watts drill is used for 1 hour, then 0.5 kilowatt-hours, or 0.5 units of energy is supplied. Here we divided 500 over 1000 to convert watts into kilowatt, then we got 0.5 kilowatt. Similarly, if a 2 kilowatts heater is used for 2 hours, then 4 kilowatt-hours or 4 units of energy are supplied. These results have been calculated by using this equation: energy in kilowatt-hours is equal to power in kilowatts multiplied by time in hours. Electricity companies charge for each unit of electricity supplied. It is possible to calculate the cost of using an appliance. Cost of using an appliance. Dear students, in this slide, we will calculate the cost, meaning electricity bill of our home, by calculating the cost of one appliance. Example: cost of using a 3 kilowatts air conditioning unit for 4 hours. Its solution is, energy is equal to power multiplied by time, or energy is equal to 3 kilowatts multiplied by 4 hour, or energy is equal to 12 kilowatt-hours. The electricity supply company charges rupees 10 per kilowatt-hours, or unit. So, cost is equal to 12 units multiplied by rupees 10, or is equal to rupees 120. Dear students, this is electricity bill in Pak currency, but here in Qatar, we pay our electricity bill in Qatari rial. I hope you have understood this question. Reading the meter. Dear students, I hope you have noticed the reading of electricity meter, fitted outside of your house. Most houses have an electricity meter, although really it should be called an energy meter. The drawings below show how the meter reading in a house changed over a 3-month period. To work out how many units, kilowatt-hours, were supplied, subtract the previous reading from the latest reading. Dear students, in this figure, previous reading is 41,710, while the latest reading after 3 months is 42,935. Now we will subtract 42,935 minus 41,710. So, the answer is 1225. Therefore, these are the total 1225 kilowatt-hours, or units consumed in 3 months. Now you can calculate the electricity bill for last 3 months of this meter. That is, cost is equal to 1225 units multiplied by rupees 10, or is equal to rupees 12,250. Dear students, now I am solving questions number 3 of Test Yourself questions on page number 99. Question number 3: if 1 kilowatt-hours of energy costs rupees 10, how much does it cost to use part A? A 2 kilowatts heater for 4 hours. Its answer is, solution, data, power, is equal to 2 kilowatts, time, is equal to 4 hours, 1 kilowatt-hours of energy costs, is equal to rupees 10. As you know that energy is equal to power multiplied by time, or energy is equal to 2 kilowatts multiplied by 4 hour, or energy is equal to 8 kilowatt-hours, the electricity supply company charges rupees 10 per kilowatt-hours, or unit. So, cost is equal to 8 units multiplied by rupees 10, or is equal to rupees 80. Dear students, you can solve the remaining parts of question 3, which are given on this page.
Homework. Dear students, please note down your homework. Write down the answers of all parts of Test Yourself questions on your notebook. Learn. Did you know, given on page number 96, 97 and 99. Solve the example which is given on page number 97. Solve the given worksheet. Write down the answers of all short and long questions on a notebook. I hope you have understood the topics taught today.
Thank you and goodbye.